Hi everyone, this is Dr. Nidhi Bansal. Today I'm presenting my paper credit card fraud detection using CNN and LSTM. We are having total 8 authors in this paper. First we are having Nishant Upadhyay from Sharda University, Greater Noida. Second author is Abhay Kumar Vajpayee from IET Sitapur Road, Lucknow. Third one is Divya Rastogi from Sharda University, Greater Noida. Fourth author is corresponding author Rekha Chaturvedi from Manipal University, Jaipur. Next author Mohammad Asim from Sharda University, Greater Noida. Next author Dr. Suraj Malik from IIMT University, Meerut, Uttar Pradesh. Next on 7th position, Khel, Prakash, Jayant. He is from Rajkumar Goyal Institute of Technology, Ghaziabad. And at last, I, Dr. Nidhi Bansal, working as an assistant professor on selection grade from Symbiosis International Deemed University, Pune, and working in its Nagpur campus, India. So we are all having individual role in this paper, and like total responsibility of this paper is mine. So I'm presenting on behalf of all the authors this paper, where we have discussed about the fraud detections in transactions or online transactions while anyone is paying the amount from one account to another account. So we are having multiple algorithms in this paper, and we propose an algorithm using CNN and LSTM. For next slide, I'm on abstract of this paper. While introducing this paper, we need to clear about the concept of transaction, why we are getting fraud transaction during the transaction of amount from one to another account. Credit card fraud is an evolving problem with the fraudsters developing new technologies to perform fraud. Fraudsters have found diverse ways to make a fraud transaction to the card holder. Thus, detecting suspicious behavior of a card is critical for preventing fraudulent transactions to happen. Artificial intelligence techniques, in particular deep learning algorithms, can tackle these credit card fraud attacks by identifying patterns that predict transactions as fraud and limited transactions. Here we are using CNN and LSTM. Both performs well on the sequential data, especially on transaction over the date. Yet there are not so many studies on these topics, but somehow they are effectively participating for this scenario to getting the better results or optimization. Here we are having some data set where we are applying some testing, which we will define in the experimental setup. So we have done some implementation where we got some optimization in the results by calculating the F score by 99.96% achieved with different perspectives. For further explanation, move towards the introduction of the paper. With the digital transaction, modern banking are getting smart transactions over the internet, as we know. So, this ease of use have attracted malicious act and increased concerns about the credit card fraud. The potential financial losses are significant, with reports indicating billions of errors lost annually in Europe alone. So the data has been fetched from different research papers or the articles also that we are having proper citation in our page. Additional with this, traditional machine learning algorithms raise concern about the data privacy. that so much concern must be concerned for the upcoming researchers and authors that should be take this scenario into consideration on priority basis. Deep learning algorithms such as conventional neural network, that is CNN, and long short-term memory LSTM have performed emerge and effectively experiments while using machine learning tools for detecting fraud by identifying irritating patterns and behavior during the transaction over the multiple type of data samples. Due to imbalanced nature of credit card transactions, implementation these algorithms faces very significant challenges also, and those challenges also we have introduced in our paper. For further movement of the paper, we are on the method or technology for this paper. The proposed method and implementation includes various major points which are listed in our paper. Those are very useful to consider in transaction while executing the summary, where we consider the scenario of credit card fraud transactions evolving over the business or over the job people while they are concerning about the money. This study investigates the viability of detecting credit card networks and the connections while assembling long-term short memory and convolutional network while we are using. This strategy may increase the accuracy of fraud detection by utilizing the advantages of both these proposed technology in processing sequential data and collecting spatial information over the channel of experiments. For further explanation for project description, the project objective is to use CNN and LSTM ensemble model to design and assess a credit card fraud detection system. Some key points also listed here like strengths, challenges, and what are the technical assets for our paper. So for the transactional system plans for execution, we have divided some points with their processing stages. Like first we are having input the process with CN, and then we are having pooling system. Over the pooling system we analyze the data after how much pooling votes for a single part of channel. While comparing it with the data set, we have designed the confusion matrix also, and while experimental setup design, we consider these confusion matrices to explain or calculate the performance matrices over the various test cases. Also, we have identified some optimization in our paper. Then we come to the main or major context of the paper, that is result and discussions. While we have conducting an fruitful experiment and implementation, we received the results with deep learning approaches approx 99.89 while calculating the F1 score and recall. Various algorithms such as NMS data, OS data, OSNMS data, hybrid mode, and SMOT data. We have calculating the results over the multiple sample of the data, various channel of the data. Also can say that CNN is properly classifying 56,916 transactions as fraud, while the transactions were legit, like around 56,687 over the channel of transaction. With the help of LSTM is also classifying the fraud transaction near about 55,224, while over we are having total 55,698 transaction over the transmission channel of the transaction. When we move with the another approach, that is assemble approach, the performance of two assemble learning models, namely early fusion, CNN and LSTM, and late fusion. It shows the early fusion is resulting better on the data set compared to the late fusion. Below will be doing to analysis of the impact of these data sets on the performance of assembles. Where we are having analysis data shows the performance of an ensemble near undersampled data set threshold under the 0.5, 0.6 and 0.7. Giving the same results in the case of early fusion and threshold with the 0.5. In the late fusion, both models have high accuracy. The late fusion outperformed the early fusion as its outputs have high accuracy while calculating the F1 score of 100% for recall also. Finally, we reached a conclusion part, that is both the models CNN and LSTM shows impressive results, generally achieving high accuracy with their F1 scores. However, some key defects exist. Data set guaranteed using LMS data and undersampling technique and MSOS data. An oversampling technique shows great accuracy and F1 score, suggesting models are doing well on these datasets. Original and scale datasets, on the other hand, exhibit lower performance, particularly for LSTM, hinted at imbalanced data or inherited challenges. Economically assembled model often surprise individual models, demonstrating the benefit of combining diverse learning styles over the period of time. Early fusion ensembles typically edge out late fusion approaches, also suggesting that fusion features before individual model predicted are more effective, especially in our paper, in our scenario where we are listing multiple algorithms with multiple sample of data over the various assemble techniques over the different transition channels. Hybrid dataset combining SMFT and MESC, the most significant came from the assemble model in the reaching near perfect accuracy in instance. So for entire conclusion, both the techniques that we have included in our paper to get some optimization results, both model C and LSTM shows their impressive and outstanding results. After calculating or receiving the high accuracy with the percentage value of F1 scores while using the confusion matrix to calculate sum over the testing, multiple testing on the test data set, which we are having collected as a sample for our scenario. For this paper, we all have done much effort, and we are very thankful for the editor sir and the team, the entire team, to accept our effort, and we are really thankful to them for supporting this type of platform where we can publish or we can show our research or work to others, because this is open access also. Sometimes editors are also getting our words by requesting sometimes for help. They are very good to listen. He is very nice in nature, so I'm very much thankful to the entire team and especially for the editor. Thank you so much. This is all about my papers, and hope I am publishing multiple paper in this journal. So I'm very thankful for the editor and the entire team. Thank you so much to all.